Hey friends, my name is C and you're watching here MakesItEasy, and welcome back to a new video for A level for the maths. And today we have 2.5 for regions in the Argand diagram for the questions video. And move on to the first question, but before we get into it, don't forget to leave a like, subscribe and ring the notification bell to let me know on any future videos. And we'll get started with the first question. On an Argand diagram, sheet in the regions represented by the following inequalities. So we have 4 inequalities, so I'll split into 4 different sections. 1, 2, 3, and 4. Actually, let's just do it more even. 3, 4. Like so. So for the first one, it's just the modulus of z is less than 3. So we know that by this, the whole form of this inequality, it shows that it's a circle, right? Because it's basically the set of points of z which are less than 3 units away from that point. So we know that the circle is centered at 0, 0, the origin, because we know that there's no other values in the bracket, it's just a z. So it's just situated in the origin, so right here. And we know that it has to be the unit 3 away from the center. So the whole radius will be radius 3. So this will be 3, the radius will be 3, minus 3, and minus 3. So we just have to connect the whole circle around. But you need to look at the sign. The sign here is less than sign, so it means that the line connecting it has to be dotted line. So therefore this is the whole locus or the circle. It's a dotted line. And let's just shade in the region. It's less than 3, that means the points have to be less than 3 units away, which is basically the region inside here. Let me just shade it properly. The regions inside here, like so. So the second question, the modulus of z minus 2i is bigger than 2. So let me just write it down here. Z minus 2i is bigger than 2. So we know that the center here is situated at 0, 2. Because we know that this I here represents the point on the imaginary axis. So it will be 0, 2, and the radius will be 2, right? So let's just draw out the Argand diagram. So it will be like this, the axis, the imaginary axis, and the real axis. So we know that the center is at 2, so let's plot 2 here. So we know that the radius is 2 and the center of the circle is at 0, 2. That means the circle will touch the origin, because this distance here is 2 and the radius is 2, that means it will touch the origin. So therefore the circle will be around here. Like so. It's a bit badly drawn, but it's basically what it is. So we can see that the region that you have to shade is the points that are bigger than 2, right? So if we were to shade the region that is in the circle, it will be less than 2, not bigger than 2. That means we have to shade the region. We have to shade all regions except the regions inside the circle. That means you basically have to shade like literally any other regions than the circle. So like this, and like so, and that would be good enough. Like so. And the third question, 1 is less than or equal to z plus 4i is less than or equal to 4. So 1 is less than z plus 4i is less than or equal to 4. So this is a circle, but it's a weird one because we have 2 different inequalities, which basically means that we have to shade between 2 locus. So we can treat it separately by just covering this, just treat this as 1, and covering this and treat this as 1. So let's just decide where to draw the circle first. So the center is at 0, minus 4, right? Because this is basically minus 4 in the center. So we have to draw a circle with radius 1 and a circle with radius 4. So let's just go through this together. So this is the real axis and the imaginary axis. So the circle is at center 0, minus 4, so this is minus 4. So the first circle has radius 1. That means, let's say minus, so we have to draw this circle here at center like so. So this will be a circle which have the center, sorry, we have the radius 1, that means this will be minus 3 and this will be minus 5, right? The point here, minus 5. And we also have to draw another circle with radius 4, because as you can see here, the radius is 4 here. That means we have to draw another circle which is bigger with a radius of 4, and it will just touch the origin, because the origin to the center of the circle is 4 units away. So we have these two locus right here, or loci. So we shade the region that is between 1 and between 4. So 1 is right here, 1, and between 4 and 4 is right here. That means that we have to shade the region that is between, which is basically this region right here. And it looks like a donut. So this will be the region to shade. So it'll be between here, like so. So just ignore this. Let me just rub this out. Oops, let me just redraw it again so that it looks nicer. So this is a region to shade, like so. So the last question, shade the region that is 3 is less than or equal to z minus 3 plus 5i is less than or equal to 5. So it's just like the one just now where we had to consider two circles. So we know that straight out of the bat we can know that the center of the circle is at 3 minus 5, and the two radius are 3 and 5. So let me just draw the Argand diagram. So this would be the Argand diagram, like so. And let me just shade this real quick because I don't think it registered. So it'll be here, right? Yep. So we know that for the last question here, the circle is at 3 minus 5. So let's just set this as 3 and minus 5 around here. Minus 5 and 3. So the circle will be centered at 3 minus 5, which is right here. So we need a circle that has a radius of 3. And we know that this distance here is 3. From here to here is 3. That means the first circle will touch the imaginary axis. So it looks something like this, with a bigger circle, like this, right? And then the second circle will just touch the real axis with a radius of 5, because we know that this has a radius of 5, or a distance of 5 from the top to the bottom, like so. Therefore the second circle will be bigger, and then it will touch the real axis, like so. Like so. It's a bit out of proportion, but let me just draw it better. So this is what it looks like. So we have to shade the region that is between 3 units away from the center and 5 units away from the center. So just like just now, we have to shade the region that is between those two, which is this region here. And then shade it in. And that is the region, and that's the answer. And moving on to the next question, we have shade on an Argand diagram the region satisfied by these two locus here. And you can see that it's an intersection. That means it's both. It's a loci that satisfy both equations. So let me just draw a big Argand diagram first by labeling the real axis and the imaginary axis, IMZ. So let's just draw the first loci, or the locus. So we have to draw the region that is the modulus of z is less than 3. So we know that it's situated at the origin. The center is at the origin, and it's 3 distance away from the origin. So let's just draw like this, like so. So this would be 3, 3, minus 3, and minus 3. So let's just look at the second one. The pi over 4 is less than or equal to rz plus 3, or is less than or equal to pi. So we know that pi is in radians, and in degrees is measured. Pi is equal to 180 degrees, and basically this represents 45 degrees, because 180 divided by 4 is 45 degrees. That means that we have to shade. That means that the half line will go from 45 degrees from the center of the argument. So let's just look at the argument. Its argument is of z plus 3. That means you know that the center of the argument is at minus 3, 0, right? Because basically it's the opposite sign. So the center is at minus 3, 0. So let me just plot that, minus 3, 0. And we know that this is 45 degrees. That means pi over 4 is 45 degrees. That means it will just cut the imaginary axis at 0, 3. Like so, just extend indefinitely. So the upper region is at pi, and pi equals 180 degrees. That means the other half line will be like this, like the whole 180 degrees, basically along the real axis, which I won't draw because it's basically along the real axis. So we know that the region of this circle right here, this loci, is the whole thing inside the circle. And the region for this argument right here is basically from this point onwards, right? This whatever point onwards. And basically the intersection point between those two regions is this region right here. That means that is the region to shade. So let me just shade it in like so. And that's the answer. And for our last question, find the Cartesian equation of part I. The locus of points representing z, the modulus of z plus 10 equals the modulus of z minus 6 minus 4i root 2. So we can just, let me just write it out first. So we can first solve it by just converting z into x plus iy. So we know that z equals x plus iy, like so. So we can group some terms, right? So we can group x plus 10 in this case because they are both the real component. And the y component is just by itself because it's the only imaginary component. But in this case, however, we can group z and minus 6 together because they are the real components. And for the imaginary components, we can group iy and 4i root 2. Like you can do iy minus 4i root 2, and you can factorize I from there. So let's just do it at one go. So the first one will be x plus 10 plus iy, close modulus, and then the other part would be brackets x minus 6 plus y minus 4 root 2 I, close bracket. So now we can basically just reverse modulus by doing square root of both sides, and x plus 10 square the bracket plus y squared, right? Do the same to the other side, x minus 6 plus squared plus y minus 4 root 2 squared. So from this point onwards, you can basically just simplify the whole equation. What we can do is that we can basically just get rid of the square root symbol to get basically this, basically, let me just make it smaller. You can just get rid of the square root symbols, or the radical symbols to be exact. So it'll be like this, right? Like so. So from now, we can basically just rearrange the equation and just cancel some terms. So I'm not gonna do it, I'll just skip straight to the answer, but I'll talk my reasoning through it. So if we were to expand this bracket right here, you get an x squared, and as well as this, you get an x squared, so the x squares cancel out. And this is y squared, and if you expand this right here, you'll get a y squared, so those two cancel out. That means the final answer will be in terms of x and y. So therefore the final answer is, let me just write it all out. It will be y equals minus 2 root 2 x minus 2 root 2, like so. And part 2, find the locus of points representing x, the modulus of z plus 1 equals 3. So we know that z equals x plus iy, so it will be modulus of x plus 1 plus iy equals 3. So therefore this becomes the root of x plus 1 squared plus y squared, or square root equals 3. So we can expand the bracket to get basically x plus 1 squared plus y squared equals 9. Right? So let me just undo this. And therefore, it will be x plus 1 squared plus y squared equals 9. And that's the answer. And part B, hence find the two values of z that satisfy both of the locus that I just wrote down. So what we can do is that we can basically just substitute y in the second equation by this y right here. So therefore it will be x plus 1 squared plus minus 2 root 2 x minus 2 root 2 squared equals 9. So from there we can basically just solve for for x. So what we can do is that we can solve for x, and the x values that I get out of from the solution is equal to, let me just draw it out here so that there's more space. So the x solution is equal to, let me just check, is equal to minus root 2, and x equals 0. So these two are the solutions, right? But we have to find two values of z, and we know that z is comprised of x plus iy. That means we have to find the corresponding x value, right? So the x value is the corresponding, we have to find the corresponding y value. So the corresponding y value for when x equals minus root 2 is y equals to root 2. And the corresponding for when x equals 0, and the corresponding y value is minus 2. Therefore, we can put them together to get z equals, let me just draw it out, it'll be z equals minus root 2 plus 2i root 2. And the other solution of z equals just minus 2i because there's no x component. And those are the answers. And for part C, we just have to draw it out. And let me just rub this part out. And just increase the size of the eraser. And yeah, so for part C, hence shade the region of the region R on the Argand diagram which satisfy both equations. So it'll be an Argand diagram like so. So the first one will be a circle, because you can see that the circle is at this. This is a circle. It will be at center minus 1 and 0. So let me just simply draw it like this. So minus 1, 0 will be roughly like this. So just don't have to be too exact. So it'll be something like this with a radius of 3, right? And then the other one will be it will be a straight line. It will be this line right here. It will have a gradient of minus 2 root 2 and a y-intercept of minus root 2. Therefore, it will cut just at this point right here, because if you were to find the intersection point, it will be in that point. So it will be around here, like so. Therefore, the regions to shade is to consider the two regions. So we'll know that for the circle, which is basically the second right here, is less than 3. That means it's basically all the regions inside of the circle. And for the line, you can see that it's basically this one right here, where z plus 10 is less than or equal to this one right here. That means it will be in this region right here, because it has to be closer than z plus 10 if you think about it. So therefore, it can just shade this region right here. So this region, and that's the final answer. And that's it for this questions video for 2.5 for regions in the Argand diagram. And I hope you will find it useful and helpful, and if you did, please hit the like and subscribe and ring the notification bell so that you don't miss any future videos. And if you have any questions or comments about my channel or my YouTube or my Instagram, you can leave them down below and I'll reply to them. And check out my social media in the description, for example YouTube or LinkedIn or Instagram. And if you need any learning resources or any teaching resources, you can check out my website in the description, or type it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and I'll see you on the next video, which will be a new topic, because this is the last video for topic 2. And in our next video, we will move into 3.1, which is the topic 3 of series. In 3.1, we'll look into the rules and examples of the sums of natural numbers. But anyways, I hope you'll find it useful and helpful, and I'll see you on the next video, which will be super interesting. But until then, stay safe and happy learning.